Okay, we are going to study reliable data transfer protocol RDT 1.0. Okay, so in RDT 1.0, what we assume that the underlying channel, that is the network layer, suppose this network layer, the packet switching, suppose we make assumptions. Suppose that it is perfectly reliable. What does it mean? That there is no bit error, there is no packet loss, and there is no out of order. Okay, so what does it mean? That if this underlying channel that physically move the data from transport layer sending side to the transport layer receiving side, it is suppose this is physically moving the data, this network layer is suppose perfectly reliable, there is no bit error, there is no packet loss, and there is no out of order. Okay, so if this underlying channel it moves the data reliably, physically reliably from the sending machine to the receiving machine. Okay, so if it is moving the data, transferring the data reliably from sending machine to the receiving machine. Okay, so what should do the transport layer for reliability? So the transport layer should do nothing. Why? Because if this channel is reliable, it is moving the data reliably without bit error, without packet loss, and without out of order. It is in order. So it is physically moving the data reliably. Then the transport layer, it should not worry about it. It should do nothing. It should do nothing because it is already moving the data reliably. So if the underlying channel is reliable, it is reliable, so the transport layer should not worry about it. Transport layer should do nothing. So what should the transport layer do? In this case, the transport layer takes the data from the application and it divides the data into packets. And then it's sent to the unreliable channel through UDT sent. But is the underlying and unreliable channel is reliable, there is no bit error, there is no packet loss, there is no out of order, so the data will be received reliably. So if the data is received, so the transport layer just receives the data and gives their data to the application layer. So in this case, in the RDT 1.0, the transport layer should do nothing. Only the transport layer should receive the data and make the packets and send the packets, and here it receives the packets and it again extract the data and again reassembles the packet and gives that data to the application. Okay, because the underlying channel is reliable, so the transport layer should not worry about it. So the transport layer should do nothing else, nothing. Okay, so how its FSM works? Okay, at the sending side, suppose one state in the FSM in one state is starting state, and their state is starting state where this arrow appears, the dash arrow. This arrow appears, so it means that state is the starting state. Okay, so in this case, the FSM at the sender side, it should have only one state. And what is the one state? That it waits for call from above layer, that it waits to receive the data from above layer. The transport layer here, it waits to receive the data from the application layer, RDT sent. So okay, so once the RDT send is called, this event happens. RDT send event happens. RDT send means that the application layer sends the data to the transport layer. Okay, so when the application layer sends the data to transport layer, so these are the actions. When this event happens, RDT send happens. As we know that in the FSM, when we move from one state to another state, so there is a transition, and this transition has two parts, the events that cause this transition. So what is the event? So here in this state, In this state, we have the event, that is this event, RDT send. When the RDT send function is called by the application layer, so this event happens, so the transport layer should do what? Since the transport should does nothing, because the underlying channel is reliable, perfectly reliable. Perfectly reliable means that there is no bit error, there is no packet loss, and the packet is no out of order, it is in order. So here it does nothing, but it only does make the packets. It arranges the data into packets, and then it sends the data, the packets, to the underlying channel. So the transport layer does two things. First, when it receives the data from application layer, it makes the packets. It makes the packet, and then it sends the packet. It sends packet means that it sends packet to the network layer, and then the network layer reliably, physically moves the data from sending to the receiving machine. Okay, so when it is sent, then again it waits for the next data. Why? Because it doesn't do anything. Because why? Because the underlying channel is reliable. We assumed in RDT 1.0 that the underlying channel is perfectly reliable. There is no bit error, there is no packet loss, and there is no out of order. Okay, and the receiving end, what it will do? So in the receiving end, it waits to call from the below, that it will receive the data from the underlying channel. From the underlying channel, it receives the data. When it receives the data from the underlying channel, so it is reliable, it is without bit error, and it is in order, so it does nothing. But what does it does? So when it receives the data from the underlying channel, so it extracts the data from the packet. It extracts the data from the packet, and then that data is delivered to the application. That data is delivered to the application layer. So when it is done, then again it waits for the next data to receive from the underlying channel. So this is the working of the transport layer at the receiver side. Okay, so at the receiver side, the transport layer is waiting to receive the data from the underlying channel, that is RDT receive this method. So it receives the data from the underlying channel when it arrives physically. And what are the actions performed? The action is performed: number one, the data is extracted from the packets, and that data is delivered to the application. Okay, so there is separate FSM for the sender. This is the FSM for the sender, and this is the FSM for the receiver. So the sender side, it has one state, and similarly the receiver also has one state. The sender sends the data into underlying channel, and the receiver reads data from the underlying channel, and the transport layer does nothing. Why? Because the underlying channel is already reliable, is perfectly reliable. So okay, so this is the RDT 1.0. Okay, now in RDT 2.0, this protocol, what does it mean? Suppose in RDT 2.0, we assume that the channel has bit error. What does it mean? That when the transport layer receives the data from application layer, so it makes the packets, and then it sends to underlying channel. Now this network layer, the underlying channel, it moves the data physically from sender to receiver. And suppose this channel, it has only bit error. There is no packet loss, there is no out of order. The data is received as it is sent. The data, there is no packet loss, there is no data loss, and there is no out of order. But there is only bit error. There is only bit error. Only bit error. Okay. So if there is only bit error, so how we can recover from the bit error? So in this case, what should the transport layer do? What should the transport layer do? Okay. So the question is how to recover from the errors. And we have already discussed that for bit error, we have discussed a scheme that is what? Checksum. The checksum mechanism is used to detect the bit error. Okay. So in this case, if there is a bit error only, and there is no packet loss, there is no out of order, the packet is received without loss, the packet are received in order, but only there is the bit error, that the bit can flipped, the bit 1 can become 0 or 0 can become 1. So this is again error. Okay, so how to recover from the errors? So suppose, how do human recover from errors during conversation? If I'm talking with a friends and I'm saying something, if my friend doesn't hear my voice clearly, so what he will do? So if he understand clearly, then he say okay, okay. If he doesn't understand clearly, he says, oh, please repeat it, please repeat it. So herely it means that when my friend is saying okay, okay, so this is feedback mechanism, positive acknowledgement, that he is understanding my voice, my talk. If he doesn't understand my talk, what he will say? He will say, oh, please repeat it. Okay, so how do human recovers from the errors during conversation? So when the human understand in the conversation, so he says okay, okay. If he doesn't understand, he says okay, please repeat it, please repeat it. Okay, so similarly here, when we have the bit error in the channel, so the transport layer should, how to recover? So the transport layer should do three things. The transport layer should do three things. The first thing is that the receiver should have error detection. Okay, so the receiver, it should have, when this channel can have bit error, so first of all the receiver should have a mechanism to detect that whether this data that is received from the underlying channel, it has the bit error or not. Okay, so first of all there should be a error detection mechanism at the receiver side. Okay, so first we should have error detection mechanism, and we have already discussed the error detection mechanism, that is the checksum, so we can use it. Okay, and the second thing is the feedback. Feedback means that when this receiver, it receives the data without bit error, so it should send acknowledgement, positive acknowledgement, that the data is received correctly without bit error. And if the data is received with bit error, then this receiver should send negative acknowledgement, that the data is received with error. So what does it mean? The sender should resend the data. So the third thing is that the sender should when send the data, so one copy is stored here. One copy is stored here. Why? Because one copy is stored of the packet. The packet, one copy is stored here. Why? Because if the receiver receives the data with bit error, so the receiver will discard the data and the receiver will send negative acknowledgement. When the negative acknowledgement received, so the sender comes to know that the last packet is received with error, with bit error. So the sender will again retransmit the data. Okay, and again one copy will be stored until and unless the data is received correctly by the receiver. Okay, so these are the mechanism. Okay, so if the underlying channel, it can have bit error, so what should we do? We should have three things. First of all, there should be error detection mechanism. Okay, and when there is error detection mechanism, there should be feedback. When the receiver receives the data correctly without error free, then the receiver should explicitly tell the sender that the packet is received. Okay, how it is sent? So the receiver should send acknowledgement. The receiver should send acknowledgement to the sender. Okay, if the receiver receives the data correctly, if the receiver receives the data without bit error, and if the receiver receives the data with bit error, then the receiver discards the data and receiver sends the negative acknowledgement to the sender. And when the sender receives negative acknowledgement, then the sender have already stored one copy of the packet, so the sender retransmit the packet. The sender retransmit the packet if the sender receives the negative acknowledgement. So it means that the receiver should use the checksum mechanism. So the transport layer should do checksum mechanism. So the transport layer should do checksum mechanism if there is the bit error chances in the underlying channel. Okay. So if the underlying channel has the bit error, so the transport layer should do what? So the transport layer should do three things. The first thing is that the transport layer should use the checksum mechanism to detect the bit level error. And second is the transport layer should use the feedback mechanism. So if the transport layer, if the receiver receives the data without error detection, without bit error, so the transport layer should send acknowledgement. And if the transport layer receives the data with bit error, packets with bit error, so the transport layer should discard the packet and the transport layer should send negative acknowledgement to the sender. And the third thing, that when the sender transmits a packet, one copy is stored at the sender. Why? Because if the sender receives the negative acknowledgement, then the sender should retransmit that packet. Okay. So now we are going to discuss, to explain this RDT 2.0 protocol, RDT 2.0 protocol through FSM. So again, at the sender side there are two states. Okay, now in the RDT 1.0 we have only one state. At the sender way and receiver we have only one state, and now we are having two states. And what are these two states? Let's explain it. First of all, these two are states. Again, in the FSM, one state is the starting state. Which state is the starting state? Where this arrow appears. Okay, so it means that this state is the starting state. So in this state, the sender is waiting to receive the data from above. From above means from application layer. So we are explaining this transport layer. Okay, so the transport layer is waiting to receive the data from above. From the above means from the application layer. Okay, so when the transport layer receives the data from application layer, so the transport layer makes the packets. But when it makes the packets, so it also have to calculate the checksum. Why? Because the underlying channel, it can have the bit error. If the underlying channel, it can have the bit error, so we have to detect the bit error. So how we detect the bit error? By using the checksum mechanism. Okay. So here the sender, it makes the packets and it also compute the checksum, and then it sends the date packet. But again note that one copy of the packet, SND packet, this packet, one copy is stored at the sender side and one copy is sent to the receiver. Okay, and now the sender is waiting for what? For acknowledgement or negative acknowledgement. Okay, so again you can see it. Okay, the sender is waiting to receive the data from the application layer, and when it receives the data, so it makes the packets and it also compute the checksum. Why? Because the checksum is used to detect the bit error. Okay, so again you can see that it computes and it sends the packet, send packet. Okay, but note that one copy of sent packet is stored at the sender side. Why? Because if the negative acknowledgement received, then this sent packet will be retransmitted. Okay, now the sender has sent this packet to the receiver, and the sender is now waiting to receive acknowledgement or negative acknowledgement. Okay, so now the receiver receives the data. So again here we see that the receiver is waiting for data from the below. So we are at the transport layer. So the below layer from the transport layer is the network layer. So here the transport layer is waiting to receive the data from the network layer. Okay, so suppose the receiver receives the packet from the network layer, and suppose So when it receives the packet, so it check that whether the packet has bit error or not. Suppose if the packet is not corrupt, it doesn't have the bit error, so what it should do? First of all, it should extract the data from the packet and deliver that data to the application layer. Why? Because this is error free. So if the packet is error free, so the data is extracted and that data is delivered to the application layer. And next, what should it do extra? This is the extra thing, that it send acknowledgement. It send acknowledgement to whom? To the sender, because the sender is waiting for acknowledgement or negative acknowledgement. So here the sender will send acknowledgement. Why acknowledgement? Because it is received, the data is received without error. And how the receiver comes to know that data is error free? So by using the checksum, okay. So again it will send the receiver will send the acknowledgement, okay. So when the receiver sends the acknowledgement and acknowledgement has arrived, so it means that acknowledgement is received. So when the acknowledgement is received, so it means that when the acknowledgement is received, so it means that the last packet, the send data packet, it is sent correctly, okay. So now the sender will come to this state. It will wait for the next packet. And the sent packet, it will be discarded because one copy is stored here. So this copy will be discarded, and now it waits for the next packet, okay. Okay, so now the sender is waiting for the next packet to receive from the application layer, okay. So this is how it works. Now suppose the sender is waiting for the next packet to receive from the application layer. So suppose there is sender is received data from the application layer. So what it will do? It will make the packet and it will compute the checksum. Why? Because the underlying channel can have bit error, so therefore we use checksum, okay. And it will send the packet to the network layer, and the network layer will transfer it, okay. So when it sends the data, the packet, okay, so one copy of the packet will be stored, one copy of this packet will be stored, okay. So again it will, and the receiver is waiting to receive the data from the network layer, okay. So suppose the sender receives the data from the application layer. It computes the checksum of the it divides the data into packets and it computes the checksum, and it sends the packet to the network layer, and the network layer has to move the packet from sender to the receiver, okay, machine, okay. So one copy of this sent packet will be stored. Why? Because if it receives the negative acknowledgement, then that copy will be retransmitted, okay. So now it is, okay, it is sent. So suppose the receiver receives the data and this received data is corrupt. Corrupt means that it has bit error. And how the receiver comes to know that the data has bit error? Through checksum, okay. So if the data has the corrupt, it has bit error, so it will be discarded. It will not be delivered to the application layer. You can see that when the data is received correctly, it is given to the application layer, but here the data is not given to the application layer, okay. So the data is discarded, and the sender and the receiver will send negative acknowledgement. Receiver will send negative acknowledgement, okay. So the receiver receives the data and it is corrupt. Corrupt means it has bit error. And how the receiver comes to know that it has bit error? Through checksum. And we have discussed the checksum mechanism in the UDP protocol, okay. So in this case, what does it do? Actions. These are the actions. The actions are, the data is discarded. The data is not delivered to the application layer. When the data is received correctly without error, it is error free, then it is delivered to the application layer. But here it is not delivered. It means that the data is discarded, and negative acknowledgement is sent to the sender. Okay, so the negative acknowledgement sent. When it receives the negative acknowledgement, so one copy of the sent packet is already stored. So that packet is again retransmitted. And again it waits for acknowledgement or negative acknowledgement. Okay. So again, if it receives the negative acknowledgement, so the one copy of the sent packet is already stored. So that copy is retransmitted. And again it waits for acknowledgement or negative acknowledgement. Okay. So suppose when this packet is retransmitted, again it is received here. When it is received here and it is not corrupt, it means that it is error free. There is no bit error. And how the receiver comes to know that there is no bit error? Through checksum mechanism. Okay, so it is error free, then it extracts the data, and the data is delivered to the application layer, and the receiver will send acknowledgement, positive acknowledgement. Okay, so the receiver does these things, and receiver sends the positive acknowledgement. Okay, so when it receives the positive acknowledgement, so it moves from the waiting state to the waiting state for the data. So here it is waiting for the acknowledgement and negative acknowledgement, and here it is waiting for the next data. Because the data is delivered correctly, so this packet is, when the acknowledgement is received, so this sent packet is discarded because it is delivered correctly to the receiver. And now it is waiting for the next data from the application layer. Okay. So again there is a error in the 2.0, and what is this error? We will discuss it, okay, in the next video. Okay.